the start. I don't do the whole thing. If you got questions, I'll bring it up there. Calculations. Are you talking about this practice test we took? So everyone in first hour said the same thing, and then calculator was easier than the no calculator, or easier than the normal? That's normal. So everyone in first hour was complaining about both parts, about how hard it was, and then I got their scores in today, and the average went up like 20 points. So one thing to keep in mind is it's a curve. So if it's a hard test, it's hard for everybody. So like if you do worse, as long as you do like less worse than other people, you can still improve. If that makes sense. We good to go? Pena, you all set? Okay. Lauren, you all set? Okay. You want to figure out who's day new? Or are we good? Alright. So are we good on these right here? Yeah. Okay. And then probability, so are we including the 1 here? Not. Are we including the 3? We are. And this means between 1 and 3, but don't include the 1 and do include the 3. So it's 2 and 3 basically. So it's those 2. So 4. And then this is why it's not equal to 2. I don't know if that's too hard to read or not, but I'm just saying like what's probability it's not 2. So you can add up these other 3 things, or you can just subtract this from 1. That's 12 over 15. And then mean and standard deviation, just to run through this process again. So I'm going to edit my list. I'm going to go up to the L1, hit clear, enter, 0, 1, 2, 3. Just type in the fraction, and it'll do the rounding part for you. You try to round it, you're estimating. If it does it, it's not estimating. So I'm putting in my data. That's stat, calc. So remember how many variables do we have here? We have 1, and it's just the number of tests. But there is information about that variable in 2 spots. So there's information in L1 and L2. And then it tells me my mean is 0.933, and my standard deviation is 0.929. Questions on the calculator process or anything here in number 4? That's basically just a review of what we did yesterday. That all good? Alright, go to Schoology if you want. Like I'm gonna go through through some notes. You can kind of come with me on school year. You can just watch up here. It doesn't matter to me. But I'm going to do, if you go to Wednesday, there's practice and there's notes. And I'm going to start with the notes. Is that big enough? Like, yep, can you see that? Okay. Evan, can you see? You can't see. You can look on your Chromebook. No, that's not good either. What do you want from me here? A little bit? Is that better? That's good? Okay. Okay, so what we're going to talk about is, like, we got a data set. We've talked about this a little bit before, but not a ton. We got a data set, let's say 3, 4, 5. We got this probability distribution. These add up to 1. Go ahead and find the mean and standard deviation of those. And then we'll type it in, draw a histogram. And then we're going to start transforming the data by, like, adding a certain number to every single data point or multiplying every single data point. We're going to curve the test, basically. Let's see what happens to the mean and standard deviation. Did you guys get 4.1 and 0.7? We good there? And then I can make a histogram of it, and you don't have to do it, because I can just do one real quick in here. Just to show you what that would look like if we were to do that. That's what we get. So what we're going through is, what if we change all of the data? So I'm going to take this, let's pretend this is like a test. Apparently people got like a 3 and a 4 and a 5 on the test. I don't know, it's out of 7 questions or something. I don't know if the test really makes sense. But let's add, I want to add 10 to every single number. So I'm not going to make this 3 anymore, it's 13. This is 14 and this is 15. Maybe I measured wrong, or I wrote down the data wrong. I'm like, oh crap, they're all 10 more than I thought they were. Do find the mean and standard deviation again of the new numbers. Actually, before you do it, will the mean change? Yeah, every single number got bigger, so the average is going to get bigger, right? Will the standard deviation change? Should. So go ahead and check it. So the mean went up by 10, right? Standard deviation didn't change. So we've talked about this before, like, all that happened was this shape, 3, 4, and 5, got picked up, moved over, and put down, and now it's at 13, 14, 15. But standard deviation talks about, like, how spread out the data is. Did I change how spread out the data was? No, so the standard deviation should not change. So if I add 10, so what's going to happen is I'm going to give you, like, I'll give you this. And say, let's say I added 5 to every single data point. What's the new mean? You would hopefully say 9.1. And what's the new standard deviation? You would hopefully say 0.7. Keep that right. Does that make sense what I'm going for there? And then let's look at what if I multiply everything by a certain number. So let's say I take my 13, 14, 15 here. Now let's double every number from the previous data set. So I will now have 26, 28, and 30. So go ahead and find the mean and standard deviation of that. Dang it, this is not going to show it how I was hoping it would. Did you get 28.2 and 1.4? So the idea is that the data is more spread out, but this graph didn't really show it very well because it just changed. It just went by 2s instead of 1s. But 3, 4, 5 would be boom, boom, boom. And then wouldn't 26, 28, 30 be more spaced out because there's 2 in between every number instead of 1. So that's the idea. So when I multiply everything in a data set, then you got to multiply the mean and you got to multiply the standard deviation. So if you multiply, both things change. If you add, only the mean changes. So let's do combination. So let's take the previous data set. Now let's double every number from the previous. Then add 5. So I will have 26 times 2 is 52, plus 5 is 57. 56, this would be 61, and this would be 65. So what I want, don't type it in yet. Try and guess what it is, and then type it in and confirm or disconfirm. Try to guess what it is, and then type it in, run through your calculations. Disprove. So this is kind of your summary. The mean is impacted by everything. Standard deviation is only impacted by multiple. So the mean up here was 28.2. I doubled every number, so I better double the mean also, so now that's 56.4. And then I added 5 to every number, so I better add 5 to that 56.4. So my guess is that it is 61.4. And then for the standard deviation, it used to be 1.4. I doubled every number, so I better double the standard deviation also, so now it's 2.8. And then I add 5, but does that change the standard deviation? It does not, so that is 2.8. So I didn't put it in to confirm, but I'm assuming that's right. Did I check it? Okay. So this is the main idea. The mean is impacted by everything. Standard deviation is only impacted by multiplying. Alright. So now go to, well, I'm going to hand this out also, but I'm going to open up this practice one. I've got this up here. So what I was going for was the original. So yeah, let me talk through this a little bit. Make it bigger so everybody can see it. So I'm just cleaning up this so I can fit it all on one screen, and then I'll talk through it. Okay, so what I'm trying to say is, like, here's the original and given mean and standard deviation, 10 and 3. Let's say I add 3 to every single data point. What's the new mean? We're starting here. The new mean would be 13, and the new standard deviation would still be 3, right? And then, yeah, so what the question is, what if multiply by 4? What I'm trying to say is multiply the original by 4. So we're still going off this 10, 3. Like, everything you do is based off the original. So then if I multiply this 10, 3 by 4, the new mean would be 40, right? And the new standard deviation would be 12. See where I'm getting that from and how I'm doing it? Yeah. Always do by the original, yeah. So then if I keep going, like double, then add 5. So for the mean, I would double it and then add 5 because the mean is impacted by everything, so that's 25. But the standard deviation is only impacted by multiplying. So I basically ignore the add 3, and I just double the original. So that'd be 6. Smell what I'm stepping in? Does everybody know you good? You're looking at me like I'm not sure. It's hard to tell with math. It's what you freeze. Alright. I'll put like the first couple up and let you guys get going. Tomorrow I think it's just gonna be a con. I haven't assigned the con yet, but I will. And then tomorrow I'm gonna give you time to work on the con. It'll be like a work day. The con's not there yet. Should I put the answers to the next part on? Is this part good? Okay. There you go. So there's the second part. Those okay? That makes sense? You're good, I'm good. I can start assign you a con. So if you want to start, you can. So I'm gonna make the con due a week from today. No, sorry, the 13th. Next Thursday. It won't be sooner than that. It's possible it'll be pushed back, but I wouldn't count on that. You got your con notifications on. Here they come. Oh, yeah, yeah. There you go. If you want to start your card, go for it. Trent's probably done it. You did it before us, right?